Okay, folks, so this is another continuation from Monday's Class Connect, where we talked about multiplying with monomials. So the main objectives of this lesson and all parts of it was to be able to multiply with multiply monomials, meaning monomial times monomial. And we got through most of that. And then we also want to talk about being able to multiply a polynomial by a monomial, which will look really familiar to you, I think. So what did we do before? Well, the big idea was to, especially a monomial times monomial, is basically multiply the coefficients and multiply the variable powers. And we multiply the variable powers by using that product of powers property, which comes in very, very handy in a lot of situations. So it's something really that you want to get used to and get ingrained in your mind. So what we did in the first part when we were live was we did review that power of products property, and we practiced multiplying monomials. And we broke it down into a 4-step process. Some of those steps can be skipped when we're more used to what's going on, but we were really talking about monomial times monomial. And we have one example of that left, and it's actually deals with a rectangle. So it's saying that we want to express the area of this rectangle as a monomial. Well, one of the things that we gotta kind of remember is that the area of a rectangle, we find that by multiplying length times width, or base times height. Either way. So what we're looking at here is basically doing 5.5 x times 3x. So let's use those commutative and associative properties of multiplication, basically meaning that we can regroup things and move them around. So instead of rewriting this as 5.5x times 3x, let's group all those coefficients together. 5.5 times 3, and then the exponents, or the variables, sorry. X times x. So now we're going to simplify our coefficients, and let's see, 5.5 times 3 I think is 16.5. 5.5 times 3, there's 15, carry the 1, 16, 1 decimal place, yep, 16.5. X times x. So there we just took care of the coefficients. And now we're going to take care of the powers of the variables. 16.5, and x times x is the same thing as x squared. And then it says to simplify it, which means combine like terms and things like that. It's already really as simple as it's going to get. So the area of this rectangle would be represented as 16.5x squared. So, and actually, it's this x squared here that is the key or the clue to reminding us that we measure area in square units, because we need to know how many squares fit into that rectangle. So just a little bit of a connection to our units of measure. So now we're going to look at polynomials times monomials, or monomials times polynomials. This is pretty straightforward with using the distributive property. We've used it before, and just as a review of the distributive property, we've used it before, like I said, to multiply something like 7 times 2x plus 3. So we rewrote this as, instead of a sum and a monomial multiplied together, we actually changed it into two monomials times monomials. So 7 times 2x, and then 7 times 3, which comes out to be, when we simplify, 14x and 21. And just to make this a little bit more general, we would write this as A times the quantity, B plus C, equals AB plus AC. I use those words, the quantity of, because I want to be able to specify that what I'm about to say next is grouped together and should be treated as a single unit. So, but this still works with any number of terms inside the parentheses. So we could still distribute this A to the B, to the C, and to the D. So we get A times B, A times C, and A times D, which is what we have. AB plus AC plus AD. And it even works in reverse. And I don't really mean in reverse. What I really mean is backwards. We're used to seeing the monomial come first before the parentheses, but it can come after. It's not very common, but it does happen. And especially when we're doing a system of equations with linear combination and multiplication. So sometimes I will write it backwards, but this works the same way. A times B plus A times C. Big question though is, why does it work this way? Why does it even work in reverse, for lack of a better word? Well, one of the big reasons is that multiplication is commutative, which means that A times B equals B times A. So what I'm saying here is A times B plus C is the same thing as B plus C times A. And that's why it works. So it's not different. It just looks different. It works the same. So basically, the steps. We use the distributive property to multiply the monomial by each term of the polynomial. And then we multiply each pair of monomials, which we've already done. So just as a review here, I was going to ask somebody to write this for us. And, actually, I'm thinking that maybe somebody even did, or they tried to anyway. Or maybe that was a different lesson that I'm thinking about. But the power of properties, power of product of powers property. Gosh, too many words all beginning with P. It is saying A to the M power times A to the N power equals A to the M plus N power. So you're going to be seeing this one a lot and using this one a lot. So here's an example of a monomial times a polynomial. Happens to be a binomial. So first step, distribute. So we get 4x times x plus 4x times 3. So we know how to do this one. This becomes 4x squared plus 12x, because the 3 is multiplied by the 4. So that's how that would turn out. We'll almost always get the same number of terms that we have in the parentheses. Let's try another one. We actually didn't really need to use the product of powers property too much on that one. This one we might. So again, start by distributing. Lots of arrows. 7y times 3y cubed minus 7y times 4y squared minus 7y times y. Okay, now I'm going to use those 4 steps that we used for monomial times monomial. So I'm going to combine or group together my coefficients, 7 times 3, and then y times y cubed. Then minus 7 times 4 times y, times y squared. Then this one, we only have one coefficient, that's going to be 7, and y times y. So now let's combine our coefficients. Here we get 21 y times y cubed minus 28 times y squared minus 7 times y times y. Now the product of powers property. Got it right that time. 21 times y to the first, y to the third, so that's going to be y to the fourth, minus 28 y to the first times y to the second becomes y to the third, minus 7 y to the first times y to the first. Whoops, I didn't need that parenthesis, so I'm going to remove that because we don't need it. So here we are. Here is our resulting product. Monomial times trinomial gives us a trinomial. So I think you're seeing it's not really as bad as you might think. Here's one that's actually in the reverse order. And it's got more than one variable. So I think that this is a good place to stop, and I'm going to come back to it in the next part.